Hello, everybody. We are continuing our lesson from yesterday where we were working. Actually, we didn't get to the multiplication story problems because we were practicing our ratio tables. Well, today we actually are getting to our story problems. And part of the reason we were working with ratio tables with these, helps if I am on the right screen. Why we were working with these is it's a one way to figure out our multiplication. Now we have to finish our answers so that everybody can at home can see our answers. And this was the page we were working on. So yesterday I had asked you to work on pages 64 and 65, and we were on 65, and here we have Raymond's table. What number did Raymond use to make his table? Raise your hand if you think you figured it out. Yes, sir.
18.
How did you figure? Will said it's 18. How did Will figure out that it was 18?
Because 306 plus 18 equals 324.
Okay, so he was the one yesterday that you used a number line yesterday to figure things out because your brain works that way. So he's at 306. And to jump to a friendly number, 310. How much of a jump is that? From 306 to 310? 4. And then we can jump from 310 to what number? 324. And how much of a jump is that? 10 to 24? 14. So 4 plus 14 is 18. So that works out quite slick. Okay, so what is the 10th row? Did anybody just do that as a multiplication problem? Luke? 180, because 10 times 18 equals 180. Is that okay that I put the 180 before the equal sign?
Yep.
Okay. Your equal sign just means the something called the same as. If you do not have page 65 open your books to page 65. I believe I said that. I could replay this if you want to hear it again, but I told you to open to page 65. Everybody should be there. Okay, so now we are at row 22. How many of you didn't know what to do for row 22? I want to just see honesty here. Okay, there are a few people who didn't understand. Okay. Look what we have right here. What row are we on? David? We're on the 20th row. So if I'm on row 20 with 360 there, and I have to get to row 22, I just need to do 21, 22. So what do I do on this side? I'm at 360, and that's the wrong number because we have to get higher than that. David?
What I would do is I start at 342, and then I'd add up to 360 to see how much I'm adding by.
And so how much are you adding by?
18.
By 18. So what is 360 plus 18? David?
378.
Okay, so we're at 378 now. 378 plus 18, that might be harder. So let's put 378 over here plus 18. Those of you who don't have an answer for that one, work on it right now. Write that down over in your margin here. If you do not have an answer for letter C, write it down. Gabby, I think that the table is close to you if you want to turn yourself, because you're in a bad place to see. If you want to use the table like yesterday, that little brown table. Is it up in front again? Oh, okay. So who knows how to add these multi-digit numbers? Who's going to walk us through adding these? David? In our ones column, we have 2 8s.
8 plus 8 is 16.
Okay, so we put our 6, carry the 10.
And then I would add 10 plus 10, which is 20.
Okay,
And then 70 plus 20 equals 90.
okay,
And I know that from 7 plus 3 equals 10. And if you subtract 1, it's 9.
okay. And then the last one?
300.
Okay. So now he was even checking his because he knew how close he was to the next 10. So or you can think of 18 is close to 20. This plus 20 is going to make certain that you get those two numbers. Okay, so there's our answers for this. How many of you remember the strategies for this multiplication wheels? It's been a while since you've done one of those. What would be the easiest number to start with? Luke, what do you think is the easiest number to start with on here? The 10. Okay, so what's 13 times 10? 130. Is there another easy number to do now? Yes, sir. Luke.
20.
Okay, so the 20 is over here. How is the 10 different from the 20?
It's double.
It's doubled.
So the 106.
Okay, so he's saying because the 10 has doubled the 20, the product here needs to double as well. Okay, what's another easy set of numbers to deal with on here, David?
Never mind. I was going to say how I did the 40.
Oh, you want to do 40? Why would you? Okay, so give me a good reason why you should do 40.
Well, no,
You've got a good reason, David. You've got a good reason. How'd you do 40?
I did 40 with the thing we learned yesterday or a couple days ago.
Oh, okay.
So double, so I did 13 times 40.
Oh, that's right, because you like the associative property. So you did 13 times 40, which equals?
13 times, thinking 42, whatever, 4 times 10. Carry the equal down, 13 times 4. And then I did 1 and 13, 2, 26, 3, 39, 4, 52. And then I brought the 52 down. And then I did 52 times 40. Or
Times 10, yeah.
times 10. And then I did the thing at the end, and then my answer was 520.
Okay. You know, I didn't learn how to do math like this till I was in 7th grade.
That can help you with the 80 too.
It can help you with the 80 too. Well, how can it help us with the 80?
I split the numbers, but you could double 40.
Oh, you could double 40. Okay, so that means we have to double 520?
Yes.
What's 520 doubled?
1,040.
1,040.
I didn't do that.
Okay. Well, hey, you guys got like the hardest numbers done. Okay, so what else can we do on here? David,
13 times 2.
what's 13 times 2?
26.
Okay.
A 30 is another easy
Hey,
number.
did you notice something here?
A 30 is another easy number.
Look at this. Look at that. Did anybody see that?
Yes.
Did you see this? Did you see that?
You add a 0 on that number. So
Oh, wait, careful with the adding the 0. You're making it groups of 10. You're thinking about it in groups of 10. That's how you end up adding your 0.
And how would you figure out the 30?
How would you figure out the 30?
You subtract 130 from 520.
Well, okay, we could do it that way. A lot of people can think of it that way. Okay. So Luke says, what do we got to do?
We gotta subtract 130 from 520.
130 from...
And that'll help us with the 3 too.
Okay. So did you hear Luke's... I don't know if you at home can hear this, but Luke was looking at this whole 40 business and the 30 business. And then if we use this, and then we subtract this one, so we're subtracting the 520 minus the 130. Oh my goodness, but that's regrouping.
So 0, and then you take 100 away.
Oh, we gotta be careful with taking 100 away because we got to look at these two numbers. And so we don't know how to do this yet correctly. Some of you have been taught how to do this, but you don't know why it works. We're not going to go there yet. We will, but we're not going there right now. So I don't want you to go there yet until you've been properly trained in this. So let's go back to this. Here's our 2, it's 26. How do we get from 2 to 3? We have to add a group. So we add 13, so here's our group.
Okay, so 390 is 30.
Okay. Because this is 3 times 13, which is 39 times 10. That's where we get this one from. We didn't do this one or this one.
Okay, so what's 4 times 10?
What about this one? Here's a double. Here's a 2 doubled to 4.
Okay, so 26 plus 26. 26 times 6.
26 plus 26 is what? 52. Do you see a 52 with some other numbers anywhere on that wheel?
So double 52.
See, look at this.
Double full.
Double 52. Look at this. Do you see all over the place here we have patterns? All over there were all kinds of patterns to look for. And in math, there are patterns. You have to look for the patterns. Okay, this one. For the problem 22 times 10, which of the following is not correct? 22 times 10 is 10 22s. Is that one correct or not correct? What do you think?
That's not correct.
Well, it's 10 22s. This is 22 10s. This one's 10 22s. Can it be this? Can it be that? So this one's correct. Okay, 22 times 10 has to be more than 200 because 20 times 10 is 200. Is that true or false? That one is true too. Okay, 22 times 10 is 22 plus 0. Is that true? No. That's the one where I always yell, danger, danger. No, you can't. When it says add, that means plus. So 22 plus 0. So you have to be careful of your terminology, the words that you use. Okay, so now we have 22 times 10 is 22 tens. Okay, so this is the only one that was incorrect. Oh boy. How many of you had problems on at least one of these down here? Okay, most of the hands just went up in class, so if you had problems at home, you're not alone. So let's think of some of the ways they were talking about this. 10, we have 10 times 19 or 19 tens. What would that be? Everybody should know this one. It is 190. Although, I hate to say that you're counting zeros, but here's our 0. We know it's for certain. Okay, so now let's look at the number 45. Wait, I want to show you something. I'm going to just put 45 here. Right? We're starting at 45, and here's our ones and our tens. If we're doing this one, now it changed to 450. Anybody see anything that we've been practicing?
No.
Okay, how many tens do we have?
45.
Well, we already have the 45 written, so what's the number that's missing? 10. We're missing the 10. We're missing that part. Oh boy, look at this one. Who has an idea how to figure out this one?
Next one's 420.
How do you know?
Because I did 21 times 10 plus 21 times 10.
Okay, so Luke broke this apart. 21 times 20, he looked at it the way that David likes to do it, where he does 21 times 2 times 10. But instead he did it so that he did the 2 last. So he put the 10 first and then the 2. So David, your favorite way? Who wants to talk us through David's favorite way?
No.
Nobody? Crickets?
I can tell you a different way.
Okay, what is 21 times 2, everybody?
42.
42. What's 42 times 10?
420.
420. If you figured that out, give yourself a pat on the back. If you didn't, yes, it was hard.
How does nobody like my way of doing it?
I don't know, but they'll figure it out.
I know.
Look at the 12. Does anybody know their multiples of 12? Let's count by 12s. Here we go. 12. What comes next? 24. 24 plus 12 is 36. Here's a 36. How many 12s did we use? Show me with fingers. 3. So we just figured out that 12 times 3 is 36. So we have the number 360. Remember this? 36. But our answer is 360. So we know we have to do 3 isn't enough. We have to do 3 times 10. What is 3 times 10? Yes. Okay, so it's 30. Or in other words, if we get our times 10, then we get our extra 0 on there, like Luke likes to say, add a 0. Okay, what about this one? Anybody got an idea? Anybody from the back? They're pretty quiet back there, those in the back of the room here. Okay, yes.
That would be 14.
You're good. You have a good try going on. I like the 4. Addison, 24. You were real close there, David. Now let's look at how this number and this number are the same. Or how are these two numbers related? Yes.
4 plus 4 is 8, and then if you add 0, 40 plus 40.
Okay, so 40 plus 40 would be 80. But now we have to be careful. We're multiplying. So how many 40s did you use? 40 plus 40. How many did you use? 2 of them. But we know 40 times 2 is 80. So what do you think that number needs to be, Addison? What? 20. Okay, now we're looking at this one. This one is a doubling times 10. So it's 84 doubled times 10. Do you see the 2? Whenever we have a 2, we're doubling. So we have to do 84 doubled. 84 plus 84 is what? Addison. Okay, so she already did the multiplying there. So we have our 8 and then we have to do 100. We have to do this times 10. And Addison tells us it is 1,680. That was really tough, huh? It will get easier, especially once you learn area model. But that's a multiplication strategy that most students in 4th grade love. So now remember, you can use ratio tables. You can use David's strategy with the associative property. Before we finish and I send you off to music, notice what we're going to be working on when you get back. We're going to be working on chickens and piggies. So some of you are going to be working on piggies. Some of you are going to be working on chickens, and we are creating chicken coops and pig pens. So that's where we are picking up with. Okay, people at home, we are pausing you. We will talk to you soon.
Bye for now. Bye for now.
Okay, hello, we're back again. We turned out that we didn't get to have music, so we watched a couple of things called Line Riders. If you want to look those up on YouTube, they're pretty cool. The first one we watched for Line Riders is called Hall of the Mountain King. Then we watched, and then one came up right after that, and it was the theme for Harry Potter. There's some really cool ones out there. Anyway, moving on to math. We're working on. Shh. I told you before we took our little break. I told you that we we're going to be working with chickens and piggies. Now, before I even tell you who's doing what, who's working with chickens, who's working with piggies, we need to know what we're supposed to do. In this activity, whoever's talking in front of me, please stop. In this activity, you're going to work together with your table groups. And you're going, you will need to figure out what the chicken stories or what the pig stories are asking you. If you happen to finish your story before the other group finishes their stories, you can move on to finish the whole page. But here we have a chicken story, and we have to answer this question right here. For those of you who can't see what it says because it's really, really tiny, it says on your book, what is the problem asking us to do? And then we have to give reasonable estimates. I have seen so many fourth graders cheat on this because they find the answer and then they put the estimate in, and their answer happens to be exactly the same thing. Their estimate happens to be exactly the same thing as their answer. Once in a while, you can estimate that well. Most of the time, you cannot. So if we go back to this page with all this writing over it, and we're looking at this, and we look at this one here where it says 22 times 10 has to be more than 200 because 20 times 10 is 200. That's what we're talking about with estimates. You're going to have some numbers to work with. And so you know what your answer has to be bigger than or smaller than when you figure this out. There are many ways to figure this out. This is going to take us a while. We're going to work for 25 minutes on this, and then we will talk about it. And then we will be out of time because we'll need to do social studies. So our stories are, Maggie's chickens live in a coop in her backyard. The coop is 12 feet by 13 feet. What is the area of the coop? If we were doing this problem, what is the problem asking us to do? Raise your hand. David, 12 times 13. Off the top of your head, you do not know what 12 times 13 is. Many of you might know what 12 times 12 is. So you could say, since I know what 12 times 12 is, it's going to be a little bit more than. And then you're going to come up with a way of figuring out how to do this. You're going to need your notebooks because you have to have a place to do your work. So get your notebooks out. I am curious. Now, for some of you, you don't know the procedure, but you always have all of your math stuff at your seat. So if some of you don't know the procedures yet, and that's okay. But most of you do know the procedures, and you know that you're supposed to have all of this stuff. Because we have a few new people in class now. It takes a while to learn the procedures. Brooklyn. Hello. Okay, Cedric's in the other class. Okay, so are you in the office right now? Okay, I will send him. Okay, thanks. Yeah, bye. Brooklyn, I guess we were early. Sorry, people. People, you're hearing a bunch of stuff. Okay, so everybody has their notebooks, correct? Okay, so if you were assigned the chickens, then you would have to do number 2. Luke, You don't know if you're going to be assigned chickens. Then it says Maggie is getting several more chickens. She built a new coop in her backyard for her new chickens. This coop is 6 feet by 26 feet. What's the area of this one? You will need to do some reasonable estimates if you're a person that's doing chickens. Then we have the piggies. Maggie's pig had just had a litter of piglets. Maggie's mother built a pen for the piglets, and the pen is 16 feet by 12 feet. What is the area of the pen? So we got to ask, what is the problem asking us to do? You write that here. And then it's like, what's a reasonable estimate? We don't know what 12 times 16 is, but we can maybe get an idea that's close. And then when you finish that, if you're doing pigs, your piglets, as the piglets grow, they will need more space. Maggie's dad is building another pen for half the pigs. The pen is 24 feet by 8 feet. What is the area of this one? Again, you will need to do your estimate first. I will be very, very, very suspicious if some of you have the exact answers for your reasonable estimates.
Every single time.
I can understand where some of you might almost be able to figure out the first one in your head, but you're not supposed to be doing that. An estimate is a quick guess based on your numbers. So this is how we're going to figure this out. Jacob's table is going to be doing the chickens, which happens to have Addison on that. Gabby's table is going to be working on the little piggies, which happens to have Tucker on that table. Oh, and Carter happens to be on Jacob's table. Ethan's table happens to be working on piggies,
Oh, sweet piggies.
which happens to have Adrian on that table.
Yay! Okay, let's make a more on.
And Trevor's on Tucker's table, so, he's working with piggies too. And Luke's on this one, and so Luke is working there. Marshall's also on. I think I've got that whole table taken care of now. So we know they're working with piggies. Phoenix isn't here. Anna's table's got to work with chickens because we don't have another group on chickens, which happens to have Reese on that table and Will on that table. Oops. Akaya. Oh, you're on that with chickens too. Sapphira and Brooklyn may make a choice. You two can decide if you're doing chickens or piggies. And if your name is not called, I'm certain that you have figured out that if someone on your table is doing chickens, you're doing chickens too. So, Will's table up in front. You guys are doing chickens. What? After you listen to this. Okay, and Trevor's table, what are you guys doing? Piggies. Luke's table, what are you doing? Piggies. Addison's table, what are you guys doing? Chickens. Brooklyn's table, what are you guys doing? Chickens. Okay, so you've got 10 minutes to do some work right now. You do? If you're doing chickens, you're doing 1 and 2. If you're doing piggies, you're doing 3 and 4. Those of you at home, we are muting while we work. You need to mute, I'm sorry, we're pausing, so you will need to pause as well. Okay, for those of you at home, I hope you are working hard on the problems. We have some students who have worked out the chickens and the pigs. And who are the people that are working on pigs again? I need to write your names down up here. Who are the chicken people? Okay, so it would be Will's table and Brooklyn's table and Addison's table. Okay, so I've got our 3 people who, the 3 kinds of people, or the 3 kinds of, 3 tables with the pigs. Looking at this, front table, shh. What do you need to do to solve what is the area of the chicken coop? What do we write here? What do we have to do? Lots of you wrote it down. Jacob, what did you write down?
12 times 13.
12 times 13. What kind of estimates did the chicken people have? Raise your hand. David?
156.
How did you get 156? I mean, did that just come into your brain? Because that's not an estimate. That's okay, I know something, so it's bigger. Mm-hmm. So what was I know something first before you're bigger? What?
144.
Okay, 144.
It was 12 times 12.
Okay. Because of 12 times 12. So that's where you started. A lot of you know that 12 times 12 is 144, so you know it's going to be bigger. Okay? Anybody else have some thoughts on that one? Okay. How did you solve this Will's table? What did you guys do?
So I knew that 12 times 12 was 144, so I knew it had to be over 144. So if it was 144, I knew it would have to be 150 something.
Okay, so how did you know to get to 150 something?
Then I put the 10 from 12 in 144, and then I put the 2 in, and that's how I knew it was 156.
Okay, so did you add a 12? Is that what you're telling me?
I added 10 and then 2.
Okay, so you added a 10 plus a 2. Okay, so you did 144 plus a 10 plus a 2. And you came up with 156. Okay. What's another way to figure this out? Other people who did the chickens.
We did the chickens too. We did all of them.
Okay, Addison, I would like you to bring your whole notebook over. I want you to look at how Addison's table set up their thoughts. When they were doing some estimate, look what they did. Oh, sorry. Look what they did. We have a 10 and a 3. What factor is that? 13. We have a 10 and a 2. What factor goes up here? So notice how they did something called the area model. They broke up 13 and 12 into the smaller factors, or in other words, they were doing some distributing. We have the 10s, we have the 1s. We have the 10s, we have the 1s. They multiplied this first box together. They multiplied the second box together. They multiplied the third box together. They multiplied the fourth box together. They came up with their answer. Okay? Thank you. I didn't think that Addison would want to talk, but she was willing to show her work. And the rest of her table they were all busy working like that. Okay, Brooklyn's table, do you have anything more to add to what you've been working on? No? Okay. So we found out that the answer is 156. Okay, people who are working on the chickens, now what do we have to figure out for number 2? Reese. 26 times 6. What did you do for an estimate? Okay, you thought about 174. How did you decide on 174? Just a good guess?
Yeah.
Okay. Did anybody think of the number 25?
No.
25 is like what in money?
Quarter.
Quarters. So if we have 6 quarters, how much is that?
30 cents.
6 quarters.
$1.50.
$1.50. So if you think of this like quarters, it would be $1.50.
150.
Or 150, yes. So that's a way to think of it too. Did you ever think of money when you can? When we're multiplying by tens, think about those as dimes. Okay, so who would like to explain how they solved this problem? Okay, Luke really wants to explain this one. So Luke, what are you going to tell us?
3.
Okay.
3.
This one? Are you doing this problem? No, this is the one we're explaining.
Okay, so 2. I did.
Okay, so let's find, this is what he's working on right now. We'll zoom in on it a little bit more. Hopefully you can see that.
So I did 6. So I did 6 times 26. Then I split the 6 into 3 and 3. Then we did 26 times 3. Then 26 times 3. Then we added the 78 and 78.
Okay. So that's a lot faster than adding 26 6 times?
Yeah.
Okay. Did anybody think about doing a ratio table?
Nope.
Oh, you guys. Ratio tables work so well. One group of 26. What is one group of 26? Then what can we do? Two groups of 26. What's two groups of 26?
32. Wait, no, 40.
52. Okay. Although I can see where you saw what Luke did, and he just split 6 in half because that was really fast. But doing what Luke did, well, gee, if we want to get to a 3, and that if we added those two together, then we have to add these two together. Okay, and then we just double this. So now we're going to double times 2. Okay, so 6, and then this doubled, 8 doubled is 16, 7 doubled is 156. You guys got the same number. Are you sure you did it right? You got the same number.
Yeah.
Are you sure that's right?
Yes.
We got 156 for the second one too.
You did too. David's group got 156.
We got 192 and 192 on the bottom.
Okay, now they're telling me that there's 192 and 192 on the bottom. Wait a minute here. But this one is 12 times 13, and this one is 26 times 6.
Let me see the couch.
Does anybody notice anything? What if I switch this around? Ooh, we got somebody that's a monkey. No, Luke, what'd you notice?
That we split the 12 in half, and we doubled the 13.
Okay. Did you hear if you didn't hear what Luke said, he noticed this one was split in half and this one was doubled. So we're getting back into looking for patterns in our factors. For some of you, this is a very, very cumbersome strategy, but it does work. If you can find patterns and you've already got this one figured out, I was like, oh, hey, well, this one's been doubled and this one's been cut in half. We're going to still have the same product. So jumping ahead, because I have to look at time and we're running out of it. This one was 16 times 12. And then the next one was 24 times 8. Do you notice the patterns again?
Yes.
12 doubled.
16
split in half. And we ended up with the same product. Now, if you remember the way that Luke was showing you how to split things apart, you can do that where we're distributing or we're doing the associative property, the way we're splitting things up. What Addison showed us is something we're going to focus on a lot when it comes to multiplication, and that's coming up soon. Okay, what you need to do now is everyone is putting away their workbooks, their math, all of their math. Those of you at home, you're going to be assigned page 67. These people will get assigned page 67 tomorrow. You guys will be ahead of them. You'll have page 67 done. So 67 is what is the assignment. Everybody else is getting ready for social studies. You guys have received that as well.
Bye!